A cylindrical can is to hold 20 pi m cube. The material for the top and bottom cost 10 pesos per meter squared, and the material for the side cost 8 pesos per meter squared. Find the radius r and height h of the most economical can. First, we let SA1 be the surface area of the side of the can, and SA2 will be the surface area of the top and the bottom of our can. Okay, so let's derive equations for SA1. And before that, we'll identify our cost equation. That is 10, which is given 10 pesos per meter squared for the side, right? So that will be 10 SA that's for the bottom. Okay. SA2 plus 8 SA1. We let this be our equation 1. Okay, so take note that we are also given value for our volume. That's 20 pi m cube. Okay, and then the formula for getting the volume of the cylinder is pi r squared h. Okay, and you can actually find the r and the h and using or manipulating this equation, but for me we'll have to find the equation for the variable h. So that will be 20 over r squared. This will be my equation 2. Actually, you can also use r, but it will look like this. Square root of 20 over square root of h. So we'll have radicands here. So I think this will be a little bit cumbersome. So I don't advise to use r in this case. So let's just use this variable h. Okay, and then for the surface area, so let's arrive equations for that. That is SA1 for SA1. Okay, so it's better to draw first. So suppose this is the can. Okay, so let us cut this section, and if we will extend that, we'll form a rectangle. This is the height of the can, right? This one here initially, and this one, what do you think is this? If we will refer that to here, this is the circumference of the can. So it was just extended because we cut a certain section of the cylinder. So area is just circumference times the height. right? And for the circumference of the circle, we have 2 pi r or pi d times the height, this one. Okay, and next is we will derive the equation for the SA2. For that is just this section, right? This one, the top and the bottom, and that is the area of a circle. And so that will be 2 because we have 2 circles, top and bottom, times pi r squared. It's just this 2, right? So the next step is that we will go back to the cost equation. Okay, so I think I need to adjust. Okay, I'm sorry because I don't have enough space in here. Okay, let's go back to the cost equation, which is this, equation 1. So substitute this one and this one into here. So that will be C equals 10 SA2 Okay, so we will proceed to the first derivative of this and equate this to 0 to find this variable r. So that will be C prime equals, that's 40 pi r plus 320. Let's take this exponent, it's negative 1 pi, or negative 1 minus 1 is negative 2. Equate that to 0. Okay, and then this area here, that will be 320 pi of r squared equals 40 pi r. R cube is 320 over 40. That is 8, right? Okay, and take the cube root of 8. That will be 2. We already got the radius, which is one of the requirements. Okay, and to find h, the height of our cylinder, then we will substitute this r into our what equation? Into our equation 2. So, okay, from equation 2, that is 20 over r squared, that will be 20 over 4, that is 5. Okay, so take note the units. So the required dimensions for the most economical can is, R equals 2 meters and h is 5 meters.